Hello and welcome to a two-part lesson, 1.7 and 1.8. For 1.7, we're going to be talking about the distributive property. Our SWABAT is to use the distributive property to simplify expressions. Quick review, distributive property. If I have a number on the outside of parentheses, I would distribute it by multiplying it to each term in the parentheses. Now this is four things that are basically saying the same thing. Number one, it's saying if A is in the front, you're going to distribute it to everything. If A is in the back, you're going to distribute it to everything. If it's plus instead of subtraction or subtraction instead of addition, you're still going to distribute it to everything. So remembering that we're multiplying, so A times B, and then in this case plus AB times, AB times AC. That's interesting. AC. Look at that. We're correcting some stuff here. This would be AB and then AC. Interesting. Of all these years, I've never caught that. So the next thing is term. A term is a number, a variable, or the product of or quotient of a number and one or more variables. For example, 5x is a term, y over 2 is a term, and negative 8 is a term. Constant is a term that has no variable factor, so it's just going to be constantly that number. Like 3 would be a constant. Negative 5 is a constant. 17 is a constant. All of those are constants because there's no variable attached to them. Coefficient is the numerical factor when a term has a variable. So if I have 5x, the coefficient is 5. It's the numerical part. If I have negative 3x squared y, negative 3 would be my coefficient. Like terms with exactly the same variable factors in a variable expression. So it's going to be the same variable and also raise the same powers. For example, 2xy and negative 17xy. Those are like terms. So are 3y squared and 5y squared. Same variable factors for each of those. All right, let's distribute, shall we? Say yes. Yes. I wonder if you said it out loud or not. So I'm going to take that negative 2 and distribute it to 3m by multiplying. And then if I want it, I can just do a quick thing here. A negative times a positive, covering those up, would be a negative. 2 times 3 is 6, and I'm going to leave the m. And then negative 2 times positive 5, negative times a positive makes it a negative. 2 times 5 is 10. What I don't want you to do is write plus negative 10. I only want one sign here. Just the one. So just make it one sign. Thank you. Now, multiplying for this one, it's 1/4 of times 8f. I like 1/4. It's a friendly fraction. Friendly fractions have 1 in the numerator, which means that all I really need to do is divide by 4. So 1/4 of 8 is 2 because 4 goes into 8 2 times, and then I'm going to keep my f. They're both positive. And then 1/4 times a negative, so a positive times a negative now is going to be negative. 4 goes into 16 4 times. You like it? I love it. So now I'm going to distribute. Boom. Negative. This is like a negative 1 though. That messes people up. Negative. It really though, if you remember from a couple lessons ago, it means the opposite. So the opposite of positive x, negative x. The opposite of negative y, positive y. The opposite of positive z, negative z. Those are actually super duper user friendly for us. Okay, now write each fraction as a sum or difference. It's kind of like the distributive property for division instead of multiplication. So what I like to do is take these two and write them as a fraction, 3n over 7. And then these two and write them as a fraction. It was positive 5 over 7. You cannot reduce either of these, so I'm going to leave it just like that. When we get used to it, these actually will look a little bit more like hearts. I know. NDR. So for this one, these two. So I have 9p over 3. And then for these two, see my heart? I have negative 6 over 3. Things that make me happy. 3p divided by 3, sorry, 9p divided by 3, spoiler alert, is 3p because 3 goes into 9 3 times. And then minus 6 divided by 3 is 2. There we have it. So basically when you're distributing, I would like for us to kind of just note that we are distributing it to each term in there. All right, let's simplify each expression. So I do see some like terms here. I see that I have 17y minus 15y. And what we're really doing here is 17 minus 15. That's what we're doing in our head, and we're keeping the y. So 17 minus 15 is 2, and then I'm just going to keep the y. I think this kind of helps us out later on when we're multiplying these. Okay, like terms. Let's group those together. These two are like. So I have 8 minus 5 is what I'm doing in my head, and I'm going to keep the xy. And then these two are like. So I have that positive 3 minus 9, and I'm going to keep that x because those are my x terms. Those are my x's. 8 minus 5 is 3, xy. And then what's 3 minus 9? Well, I'm going to add the opposite. 3 plus negative 9 is negative 6. And then I'll just keep the x. You like it? I'll do. Okay, so I like to start with a bigger one typically. There's nothing really alike with this, so I'm just going to go ahead, negative 6k squared. But these two are like terms. I have negative 5 minus 12k, and then I have that plus 10 I'm not doing anything with. Okay, negative 6k squared wasn't a like term for me. Negative 5 plus a negative 12, I just added the opposite, gives me negative 17k, and then that plus 10 at the end. That's it. Okay, a little bit of geometry, very, very low-key. Find the area of the rectangle. So remember, area of a rectangle is area equals length times width. So I'll make this the length, does not matter which one you name for which. So my area equals the length, 15, times the width, x minus 3. And then I will distribute. 15 times x is 15x. 15 times negative 3, positive times a negative is negative 45. Beautiful. All right, now we're going to combine what we did for this group, distributive property, and the simplifying group area. So first thing I want to do, order of operations, is to multiply. So I'm going to get rid of my parentheses. 5 times n, 5n, 5 times 8, minus 40. Distributing here, 6 times 7 is 42, positive 42. 6 times negative 2n is negative 12n. Like terms, 5 and negative 12. 5 minus 12 n. And then I have negative 40. What is this going to give me? Negative 40 plus 42. The signs are different, so I'm going to subtract the numbers and get 2. And I want to keep the sign of the bigger number, so positive. And then these two, when I add them up, adding the opposite, I have negative 7n. I'll just bring down that plus 2. Okay, one more for 1.7. Distribute first, if you would, please, and then I want you to combine like terms. Do me a favor and press pause right now and literally distribute, boom, 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 and then I want you to combine like terms. So add your s's and your t's together, and then check your work when you're done. All right, so when I distributed, I got this, negative 10 plus 8s minus 12t, and then I grouped my like terms together, so 8 minus 5, and then negative 12. They don't give me a number in front, so I just put a 1 in front of that t, so negative 12 plus 1, and then this would be my final answer. make it official. All right, so 1.8 goes a little something like this. An introduction to equations. SWABAT, solve equations using tables and mental math. Actually, we're not going to do that. Mostly what we're going to be doing today is checking solutions, because that is what I mostly want us to be able to do. And then we're also going to make sure that we could write some equations, some expressions, some equations given words. So, an equation is a mathematical sentence that uses an equal sign. Makes sense. Equation, equal sign. Open sentence is an equation that contains one or more variable and may be true or false depending on the value of its variable. Solution of an equation is any value or values that make an equation true. So, step 1, tell whether each equation is true, false, or open. Open could be either one, but it depends on the variable. Either one could be, but it depends on their variable. Okay, so let's simplify on this left side. I will add the opposite here and get negative 52. Does that equal negative 52? Every day, all day. So this is true. And then for my next one, we're just going to use order of operations. I'm going to start with the left side there. And so I'm going to multiply first and get, and if it's still helpful, you can do your cat face. Positive times a negative will give me a negative. 3 times 6 is 18 plus 5. And then 26 minus 3 is 23. Is negative 18 plus 5 23? No, it's negative 13. So this would be false. You lied to me. This one I could solve, but I don't want to, and I don't have to, because the question is this true, false, or open? Because it has a variable, it's open to interpretation. It depends on what the variable is for that one. All right. Tell whether the given number is a solution of each equation. So now we're just verifying some things here. So here's my equation, pause at that semicolon, and they're saying x equals negative 2. I want to know, is that true or not? So what I'm going to do is take that negative 4, and then where it says x, I'm going to put negative 2 plus 7. Does that equal 15? I don't know. What's negative 4 times negative 2? Negative times a negative is positive. 4 times 2 is 8. Plus 7 is 8 plus 7 equal to 15. Why, yes. Yes, it is. So that's true. Okay, do me a favor. And for the next one, where you see a C, put 3 and then simplify. Press pause, please. Press pause. Plug in C and then. Alright, so there's my work. If you didn't do it by yourself, go ahead, press pause and copy mine. Cheaters! But I got true for that one when I plugged in 3 for C. Alright, next. Write an equation for the sentence. So here's my sentence. Equation means I should see an equal sign. One thing I want you to know is equal. So that's how we will interpret that. When we see the word is, that means equals. Just like for when we see difference, we know that means subtraction. And so the difference of a number, let's pick a variable. I'm going to pick f for fits and 7. So f minus 7 is equals 8. Don't solve. That's all they want me to do is just interpret. We're just interpreting. Okay, next one. 6 times what though? Times the sum of a number and 5. So the sum means addition of a number, so I can pick my variable for that one. I need to add a number, m, and 5. 6 times the sum of a number and 5 equals 16. Alright, Josie is 11 years older than Mary. Okay, what is an equation that relates the age of Josie, J, so J, and Macy, not Mary, Macy. Josie is, so equals 11 years older than Macy. So here's Macy's age, and she is 11 years older than her. Yeah, I like that. Okay, last group, guys. Last group. Tell whether the given ordered pair, so remember ordered pairs are x and y. Alphabetical, x will always be first, is a solution of the equation. So let's label, if you don't mind. This is my x, this is my y. This is my x. That's funny to say. So instead of y, -2 equals 2 times x. What's my x? 7 minus 3. True or false? Let's simplify to find out. 2 times 7, order of operations, I'm going to multiply before I subtract, is 14. That is nowhere near being true. So I'm going to say no, it's not a solution. Ooh, fraction action for us. Love it. First thing though, I want to label. Label first, always. So I have 1/2. It's a friendly fraction because I have 1 in the numerator, times x, which is -4, plus 5 equals, instead of y, I'm going to write 3. Friendly fraction means I just need to divide by 2. So -4 divided by 2, or half of 4, is 2. And it's negative, plus 5. Is -2 plus 5 3? Yes, it is. So it is a solution. All right. Well, that was 1.7 and 1.8. Thank you so much for joining me, and have a wonderfully blessed day. Bye-bye.